Assalamu alaikum, hello everyone. Today we will be solving this question about waves and superposition. It's from Cambridge International AS Level, Physics 9702, paper 23, May-June 2021. Okay, so let's get started with question 4, part A. State the principle of superposition. Okay guys, so the principle of superposition states that when two or more waves meet at a point, the resultant displacement is actually the vector sum of the individual displacements of those waves at this point. Okay, so for the definitions, guys, I really advise you to memorize them from the mark schemes. Okay, part B. Two waves with intensities I and 4I superposed. The waves have the same frequency. Determine in terms of I the maximum possible intensity of the resulting wave. Okay guys, so let's move here a little bit. I'm gonna solve this here since I need some working area. Okay, so we have a wave of intensity I and another wave of intensity 4I, guys. These two waves will superpose, producing another wave. Let's say the wave was like this. Okay, so guys, you need to know that intensity is directly proportional with amplitude square, right? So we can say here I1, which is intensity, over 4I, which is I2, equal to A1, which is the amplitude of the first wave, over A2, the amplitude of the second wave, whole square. So guys, now we can get rid of I and I. We are left with 1 over 4 equal A1 over A2 whole square. We can take the square root. Square root of 1 over 4 is actually 1 over 2 equal A1 over A2. Cross multiply, so A2 equal 2A1. Okay guys, so now when the two waves superpose, from the definition of superposition, you should know that we add their amplitudes. Okay, so 2A1, which is A2, actually the amplitude of the second wave, plus A1 equal 3A1. Okay, this is the resultant amplitude, but they are not asking about the resultant amplitude, they are asking about the resultant intensity, guys. Okay, so we know that intensity is proportional with amplitude square, so we can just replace A by 3, so 3 square is actually 9, so the resultant intensity will be equal to 9I. This is the answer for this part, guys. Okay, let's go back. So this one will be 9I. Okay, part C. Coherent light of wavelength 500 nanometer is incident normally on double slit of slit separation 0.35 millimeter. Okay, a series of bright and dark fringes formed on the screen placed a distance of 1.2 meter from the double slit, as shown in figure 4.1. The screen is parallel to the double slit. Okay, determine the distance between the centers of adjacent bright fringes on the screen. Okay, so guys, we know that lambda equal AX over D. Okay, where D is the distance between the screen and the light, and lambda is the wavelength. A is the distance between adjacent slits, and X is the distance between the fringes, between adjacent bright fringes. So we need to find X, so X is equal to lambda D by A. Now lambda equal 550 nanometer, you should convert to meters, so everything is in the SI base unit, times 10 to the power minus 9 into D. D is 1.2 times 1.2 over A, which is the distance between slits, which is 0.35 millimeter. We should convert it to meter. 0.35 times 10 to the power minus 3. Okay, add this to the calculator, guys. 550 times 10 to the power minus 9 into 1.2 over 0.35 times 10 to the power minus 3. We will get our answer as 0.0019 meter. You can write it like this, or you can just say 1.9 times 10 to the power minus 3 meter, guys. 1.9 times 10 to the power minus 3. Remember, guys, you should always write your answer to two significant figures unless otherwise is mentioned in the questions. The light of wavelength 550 nanometer is replaced with red light of single frequency. State and explain the change, if any, in the distance between the centers of the adjacent bright fringes. Okay, guys, we know that X equal lambda D by A, right? Okay, exactly, X equal lambda D by A. Now we replace this wavelength with red light. You need to know the wavelength of red light, guys. If the wavelength is actually greater than 550, so the distance will increase. If it was shorter than 550, the distance will decrease, guys, since x and lambda are proportional to each other. So guys, you need to know that the wavelength of the red light is about 700 nanometers. So D and A are actually constant. So x is proportional to lambda. The wavelength was about 550 nanometer, and now the wavelength is about 700. So lambda increases, so x must also increase. So we can say distance will increase since wavelength have been increased, or wavelength increase. Okay guys, so that was the end of this question.